Hello, everyone, and welcome to our latest State of .NET webinar, the state of the Microsoft Azure Cloud. My name is Jim Duffy, and I'm responsible for the marketing and sales efforts for all of our code services, including Code Magazine, of course, but oh my goodness, code is so much more than just a magazine. Code Consulting, for example. Code Consulting's continuing mission is to help people build better software. We are a Microsoft partner and provide a number of solutions, including building custom software solutions on-prem and in the cloud, educating developers, modernizing legacy applications, providing developer resources to augment your development team, and supporting and maintaining existing applications. Our team of expert developers and consultants are ready to help with your project. One of the very popular free services we offer, we call our Free Hour of Code. It provides an opportunity for you and or your team to meet with our expert team to discuss anything you could use our help with. Slots are limited, so reach out to me today to get your free hour of code scheduled. There are no strings, no commitment, no credit card required, just free help from our code experts. We are hiring developers. Come join the Code Consulting team. We have multiple junior and senior level positions currently open, remote and on-site. Full-time and contract positions are available. Follow the link below for more information. Are you down under? Are you looking for your next adventure? A job where you can work remotely full-time with an ongoing contract along some of the best engineering minds in the software field? Then Code Consulting is for you. We are looking for developers in Australia, New Zealand, or in any of the neighboring countries. Please check out the job offerings below. We'd love to have you with us. If you like what you see today or have seen in our prior webinars, please ring that bell and subscribe to our YouTube channel. Follow us on Twitter, like us on Facebook, and follow us on LinkedIn. Code Magazine is the leading software development magazine written by expert developers for developers. All registered attendees who don't already subscribe will automatically receive a free digital Code Magazine subscription. I've also included a free subscription link here for you to freely share with others who couldn't make it to the webinar. Just a reminder that the Code mobile app is available for both iOS and Android. It's the ideal way to read Code Magazine on the go. We would like your feedback about this webinar in the form of a quick survey, and we're willing to pay $100 in the form of an Amazon e-card to one lucky attendee. The lucky name will be drawn from the list of submitted surveys. The survey link is on the slide, and we'll post the survey link in the chat window. The slides and recording of today's webinar, and all of our webinars, will be available on the State of .NET page on the Code website. I've included that link here. This State of .NET webinar is sponsored by DevSkiller, the most candidate-friendly tech talent platform. DevSkiller is the industry-proven platform to assess and grow tech talent. Created by developers for developers, DevSkiller is powered by the real-life testing methodology. With customers in over 90 countries and candidates in over 150, DevSkiller is ready to help you assess tech talent wherever you are. DevSkiller Talent Score helps you assess and hire tech talent based on real-life programming challenges. TechScore is the most realistic technical screening platform on the market, with 0 whiteboards in sight. Talent Score features over 5,000 off-the-shelf tasks, workflow automation, options to add customer-specific business exercises for technical assessments, and popular ATS integrations. Talent Score is focused on candidate experience with a 94% test completion rate and provides hiring managers with detailed reports and analytics for data-driven decision-making. Before saying, "You're hired," make sure you assess their development skills with DevSkiller and Talent Score. Our presenter today is Marcus Egger. Marcus is the big kahuna around here. He's Code President and Chief Software Architect, publisher of Code Magazine, international author and speaker, Microsoft Regional Director, and a very knowledgeable and talented developer. If this is your first time attending one of our webinars, welcome, and thank you so much for joining us. If you've attended one of our webinars in the past, welcome back. Okay, you've heard enough from me. Thanks for listening. Take it away, Marcus.
Thank you, Jim. Hello and welcome everyone, wherever you might be in the world. I see we already have quite a few people online from all over the place. So that's going to be some fun today. We're flying a little bit by the seat of our pants today, operating with the skeleton crew here. Like everyone else, a lot of people seem to be having COVID and it's hit us too. So we're missing some of the key people. So I'm trying to do it all with just another person or two. Like always, we're still going to try to answer all your questions online. It's a live presentation, so feel free to send us some questions, and I'll have my control center over here. So if I'm looking off screen, that's not because I'm ignoring you, it's because I'm actually looking at what's going on with questions. And yeah, so we'll have to make do. Ian, our brain and heart behind our streaming operations, is out, unfortunately, but somehow we'll make do, I'm sure. So what are we going to talk about today? Obviously, the topic is Azure. So all things Microsoft Cloud. It's a humongous topic. So what we want to do is we want to get the big picture, kind of Azure by the numbers if you want. What are the important developments that we've had recently? What's the stability of Azure? What are some important developments you need to be aware of? But also in the bigger picture, how do you move to Azure? What do you expect if you have older existing software that you need to move? All those types of things. We'll talk a little bit about AI and machine learning. We'll have some samples. We have different levels of content. It's always being pointed out to me that there's quite a few people who have not made the move to the cloud yet. It's been around for a while, but of course people don't get adopt all this new technology very quickly necessarily. So towards the beginning of the presentation, we'll do kind of a very fundamental thing where we take a first look so people can all be on the same page. If you're very familiar with that already, as most of you probably are, or many of you probably are, I should say, bear with me. It's only going to be a short segment, and then we get into some of the more sophisticated stuff. And as always, I'm trying to do a good mixture of samples as well as slides and just talking through some points, because there's just too much to cover and we can often only scratch the surface. And also, Jim already mentioned that in the intro, but I do want to state that again. Consider us a resource. If you have any questions about any of this, a lot of times people after the presentation contact us and say, oh, that's all nice and good. Tell me how this applies to myself and my project. Well, if that's the case, first of all, you can ask questions while this is going on, and I'll try to answer as many of them as we go, and then I'll stick around for a bit afterwards to answer questions. But feel free to contact us at any point after the presentation. We are a very community-oriented company. We're happy to answer your emails. Little bit of a hint there. It's better to email Ian or Jim to get a quick answer. I will answer all the emails I get, but sometimes it takes me a while, to be perfectly honest. But like I always say, we're not the kind of company that's going to send you a bill for a quick email answer, or even a longer email answer. So just feel free to consider us a resource. So with that said, let's dive in and let's get started with the presentation. And the first thing I want to say there is welcome to 2030. What do I mean by that? Well, I actually mean the year 2030. Well, that's preposterous. What's the statement doing here? Well, one of the overarching themes that I currently see when it comes to development in general, but the cloud is a very big factor of that, is that we have made a huge leap forward. When you look at what's been happening over the last 2, 3, and maybe even a little more years, one of the things that's clear is that the IT landscape, and especially the landscape for software development, has changed, and it's changed in a way that's going to stick around. So many of the changes that we have seen over the last years, they're not going to be reversed. And the problem that a lot of companies, whether that's in-house departments or whether that's software provider, the problem a lot of those companies have is that the software that was aging but still kind of did the trick is just not working so well anymore. We now have people working from all over the place. We have people expecting new patterns of work. We have companies expecting to hire people from different places. We have companies expecting to work together with other companies in different ways. And a lot of that has just changed things fundamentally. And there's different estimates what that actually means. Some people say we've leapfrogged 5 years, some say as much as 10 years. Whatever the case might be, it is clear that we have moved very, very quickly into a world that we anticipated to see maybe around 2030, which is why I picked that round date there for that somewhat strong statement, let's call it that. So what does that mean? Well, that means we have a lot of software to write. We have a lot of software to rewrite. We have a lot of software that doesn't satisfy the needs anymore. And we have about 8 billion people relying on us for that. And we have about, give or take, depending on how you count, 30 million developers worldwide that somehow have to cope with this. And long story short, we can't cope with these problems that are coming our way if we don't leverage existing infrastructure and services. And the cloud is a major enabler for this. The cloud is a major enabler for smaller organizations because you can simply play with the bigger players in ways that we couldn't before. It's a big enabler for large organizations because even for large organizations, it was very difficult to operate data centers and global distributions at the level and reliability level that we are now expecting to see. And of course, it's a major enabler for everyone in between. So that's kind of the setting of the stage for today's presentation. That's the world we now live in. And we need to satisfy these needs of the people that want both software that's secure and distributed and available everywhere. It has to be available on your PC. It has to be in the palm of your hand. We expect software to be ubiquitous. We expect it to be available everywhere. And as if that wasn't enough, of course, we expect software to be very, very sophisticated. There's very few scenarios today where we wouldn't see some kind of intelligence behind modern software. And I'll show you some examples of that in this presentation. And then the next data.net actually completely focuses on that. So we'll just tip our toes into that a little bit today, but then talk about that more later. Today we'll focus more on the Azure side of things. So where are we at with Azure? What's the state of Azure, to stick with the title of this presentation? Now, one of the things about Azure is that I'm tempted to say that it has reached a certain point of stability. Now, that's a little bit of a strong statement when you see how many new things are coming from the Azure camp and how that wheel seems to be spinning faster and faster and faster with more and more things becoming available on Azure. But what I mean by when I say that it's reached a certain point of stability is that we are now seemingly past this mode of operation where there's a new service and then we start using that, and then a few months or a year later that service is replaced by something else, and you kind of don't necessarily start over. It wasn't usually that hard to move between those, but nevertheless, there was a lot of churn and a lot of new stuff, and you were never quite sure what the thing is that you were really supposed to use. We still have a little bit of that, but the characteristic of Azure, I think, has changed in that it's much more mature, and you actually have services that are more gradually improved. So when we talk about a lot of things today, you'll notice that if you've been around Azure for a while, you'll see the same things that you've seen before, just with a lot of new stuff added rather than completely different things. So that's good. It's a sign of a well-established platform, I think. And not to worry, there's plenty of new stuff coming, a lot of stuff that builds on top of existing things. And like I said, overall, the wheel is spinning faster than it has been in the past. It's just not as wobbly anymore, I guess, if you want to think of it like that. Now, a considerable percentage of companies at this point use the cloud for one reason or another. And I have some other slides that have some more numbers on that. And you get different numbers from different sources. But the point is, a lot of people are moving the cloud. There was kind of a first wave of adoption, small percentage of people that were the early adopters. Then there was a second wave, and a lot of people moved along in that second wave. And on the tail end of that is the COVID crisis and people working from home and people having to move onto the cloud almost in an emergency scenario. But not everybody is on the cloud yet. Of course, technology evolves at all kinds of speeds. Some companies had large investments into their own data centers. Some companies simply didn't see the need for the cloud. So we do see in the market that there's quite a few people left that haven't moved yet, but it's really seeming like almost everybody is now talking about moving. So if you are in the camp that hasn't done anything with the cloud yet, not to worry, you're not alone, but it's probably good to start thinking about using the cloud in some fashion, and we'll talk about different scenarios as to how that can be done. Now, when we talk about the Azure cloud, one of the things we always get asked is, what is the market share of the Microsoft cloud? And you can look at this in a number of different ways. It depends a little bit on what you count. Is it just the development stuff, the platform as a service, the infrastructure as a service? Some of the things built on top of that are now almost software as a service. So there's different categories of things, whether you just use a computer that's in the cloud or a specific service or thing that is made for you as a developer that provides a certain feature set, or whether you subscribe to a whole software package like Salesforce or something like that. So you'll see different statistics, and I've shown different statistics in different presentations if you've been in my presentations before. But at the end of the day, it always looks very similar to this little chart that I've chosen to show this time. So AWS is in the lead. So the Amazon guys have a very, very solid offering for the cloud, and that is very, very popular on a global basis. So arguably about a third of the world's cloud needs run on top of AWS. And then there's Azure. Azure is a very, very solid second, and then there's a big gap to all the others. And I think the order that you see here is usually very similar, and sometimes changes a little bit again depending on how you count. But the bottom line is AWS, the Amazon cloud offering, is in the lead. Microsoft's Azure cloud is in second place very solidly, and those two players are by far the most important players in the cloud market. And we're going to talk about Azure here today, but that is not to say that AWS isn't any good. It's a very, very solid offering. There's lots of reason why people move or use AWS, but Azure is also a very, very solid offering. And to us, it's the one that we choose more often than anything else, even though we also do some AWS work. And I'll talk a little bit about why that is. Now, when you look at how this market share develops over time, you'll notice that AWS shrinks a little, while the Microsoft offering is very solidly growing, especially amongst enterprises and the high-end users, while AWS tends to be a little more appealing to everyone, but certainly also the startups and all that. Now, I think that's very natural. If you're the big leader, some other people are going to start nipping at your heels, and therefore, where's that market share coming from? It's coming from the leaders. So all of that is, I think, very much to be expected and indicative in my mind of a very healthy ecosystem. And it's also important to realize that you don't have to pick and choose. You can mix and match things. So if AWS has an offering that you really enjoy and it supplements what you're doing on Azure or vice versa, then that's certainly a scenario that's very, very usable. Now, how big is this thing? How big is Azure? Well, we've now gone through the numbers a number of times, and of course, every time I bring up a slide, all these numbers keep going up. Currently, there's, unless I've missed something in the last few days, 78 data center regions around the world. Data center regions are not necessarily data centers. They're often collections of data centers, which has to do with logistics and availability and so on. So Microsoft currently operates more than 200 physical data centers around the globe in all kinds of different incarnations. And those are all very, very massive undertakings. If you've never seen how what this looks like, I have some photos that I have coming up in my next slides here. But long story short, these are massive operations. Think warehouse size operations, multiple warehouses in a single data center. Then you can look up all kinds of amazing statistics, like one stat that I think is interesting. There's 175,000 miles of fiber optics that Microsoft uses to tie all that stuff together, and lots of very impressive numbers like that. Now, a lot of these data centers, or all of these data centers, when you look at them, they're also very physically secure. So getting into one of those data centers is very, very difficult. Getting into one of those data centers, if you have anything metallic on you, is very difficult because they have all these metal detectors and making sure you're not taking hardware out and so on. And in fact, hardware doesn't generally leave one of those data centers. So if a computer goes bad, a server goes bad, a hard drive goes bad, that is not taken out to be repaired. It actually goes into a huge shredder that is capable of shredding massive amounts of hardware. Like you could literally throw Volkswagen Bug into one of those shredders, and I think it would shred it, is what I'm told. Whether that's true or urban legend, I'm not sure. But the point being, these are massive and they're very secure, and all of that is being taken very, very seriously. So I have a few photos here from data centers, like this is the Quincy data center Microsoft operates. And these photos are actually not totally up to date. This has probably grown quite a bit, and there's other data centers being added. Here's one in Cheyenne, which was still being built out, I believe, at the time this photo was taken. One in Dublin. I'll give another one from Amsterdam. So as you see, these are very, very large operations. And Microsoft has now become a landowner of considerable size just because of all these data centers that they operate. And that's truly mind-boggling. And they're popping up one after the other. It's literally down to where Scott Guthrie once told me he would have never thought he'd worry about how fast concrete can dry, because that's kind of the level at which they're pushing. They're really up against boundaries like that, where they're trying to push as hard and as fast as possible to add more to their current data center lineup. So truly mind-boggling developments. We're talking about some data centers that are underwater and all kinds of fancy stuff. Some of that, of course, is not disclosed to us for security reasons. And in any event, you get the idea. This is serious stuff. One of the biggest undertakings that any IT company has ever tried to do, and that's both on the Microsoft as well as the AWS side, of course. But it's impressive. It's if you ever get the chance to tour one of those data centers, which is unlikely, but if you get that chance, I would suggest you take advantage of it because it's super impressive. So who actually is using the cloud? Well, the short answer that every company always gives you is most of the Fortune 500 companies are using the cloud. So if you go to Amazon, they say something like 80% plus of all the Fortune 500 companies are using AWS. If you go to Microsoft, they'll tell you 95% or more of all the Fortune 500 companies are using the Azure Cloud. Now, obviously, they're not splitting the market. Obviously, there's a lot of overlap. And again, that's one of the key takeaways is if you start using the cloud, you're perfectly free to use different providers for different needs. So you might want to run the microservice on one cloud, and you might want to run some AI on another cloud, and maybe a database on yet another cloud. Now, architecturally speaking, there's some considerations there. You don't want to have a high-performance website where the database and the microservice that uses it are geographically and infrastructure-wise far separated, because it's going to limit your performance. But very often you'll have a microservice with its data structure that does a certain thing on one cloud, and then maybe another microservice that does something else with its data structure on another cloud. So those kinds of things are pretty common. Or you might want to build your application and it mainly runs on one cloud, and then you have this AI piece that a certain cloud does really well, and you use that and combine those two that way. Okay, so large companies are using the cloud to a very large extent. I've personally, in my professional career over the last year or two or three, not encountered any Fortune 500 company that didn't have any kind of cloud initiative underway where they used it at least a little bit. Of course, a lot of these large companies also have a large investment into their own data centers, and some of them even build their own cloud, but even those most of the time now start to blur those lines and start using some technology from some of the clouds. And the Azure Cloud offers some services that even allow you to manage your own data center or things that sit in other clouds from an IT management point of view. So it's a very cool stuff going on there. So that's the large companies. Now the small companies, it's a little bit of a different effort, and I have no idea what the percentages of small companies that use the cloud. But I think it's fair to say that especially recent small companies that have started up over the last 5 years or so, are very, very solidly grounded in the cloud and are enabled to do things that, especially as a small and resource crunched company, you otherwise just wouldn't have. Right? There's so many new startups coming out that use the cloud, and they use all these things that if they had to put up 1,000 servers on their own to support their effort, would just be impossible. So who is not on the cloud yet? Well, it's very anecdotal, but just based on what we see in the market through our consulting and training and magazine efforts and so on, medium-sized companies seem to be the ones that are holding out the most, because they may have an investment in other things and are not necessarily able to move as quickly. So we see that. We also see some older small companies holding out because they're just, I guess, set in their ways as long as they can. But then again, this whole welcome to 2030 thing overwhelmed a lot of these small companies. And they're now often sitting there thinking, well, how can we fix this? Not realizing the benefits of the cloud and how easy they could often get those benefits. That's one of the things that I see a lot where people think, oh, it's going to be really, really difficult to make that move, when in reality, it probably doesn't have to be. And I have some slides about that. Now, one of the main reasons that we often hear about when people don't want to move to the cloud is security and trust. They say, why would I give my data to companies like Microsoft or Google? Might be kind of a scary example. And I think that has largely been a red herring. I think over time we have now seen that there haven't been any real issues with cloud providers stealing data, certainly not at a systematic level. And I personally haven't really heard anything like that. And we have our fingers into a lot of things, so it would seem that we would have heard about this. And the cloud providers, of course, have a keen interest in making sure that this doesn't happen, because the overall value of the cloud to them is so much greater than trying to steal your customer database and the value they get out of that, that's just not a very appealing scenario, especially if you're like Microsoft, not in the business of selling data like some of the others are. So I think this hasn't turned out to be an issue. Quite the contrary. We've now seen that there's initiatives around trustworthy computing, where you have ways to actually put data into the cloud where companies like Microsoft wouldn't even have access to that data, even though it runs on their own systems using encryption and all kinds of other stuff. So that's very interesting to look into. And if you're concerned about this, feel free to contact us. It's certainly something that we can talk about. But long story short, this has not turned out to be an issue for anyone that I'm aware of. Now, if it comes to security more in the sense of being attacked from the outside, in this scenario, the cloud has worked out really well, because the simple fact of the matter is that a company like Microsoft or Amazon simply can spend a lot more money on infrastructure and talent that fights all kinds of different attacks. And some of you may be aware of this. We've had an issue ourselves a few years back where we were the target of a massive ransomware attack, which actually took us down for a little while. And I've done presentations around how we recovered from that. But the long story short is that the cloud was a very, very instrumental piece in that for us. We had some stuff on the cloud and not other things before that happened. We then, in an almost emergency panic scenario, moved a lot of things to the cloud in a matter of days. And some of that then had to be massaged and changed over time. But it was actually interesting to see how straightforward some of that was. Now, it took a while to upload data and things like that, so it took us a few days. But all in all, it was actually relatively straightforward. And this scenario of trying to fight off a ransomware attack or anything similar would be extremely difficult for us. And even with the experience we now have, we just don't have the same capabilities as Microsoft does. And we don't have the same capabilities in terms of having redundancy and geographic replication and all that type of stuff that Microsoft was able to do for us there. So with that in mind, I sleep a lot better knowing that practically all our infrastructure is now in the cloud. Looking back at what has happened with our ransomware attack, we were able to fight it off. We were able to not pay anyone any ransom. We didn't lose any data or anything like that. It took us a few days to be back up and running. Had some difficult backup and restore operations. But the data that was already in the cloud actually turned out to be the most secure and didn't really even have to be recovered with a lot of the cloud technologies and largely just wasn't affected at all So only the things that were in our own data center and offices at the time were affected. So I've become a big believer, as are many other people, that using the cloud for the very purpose of being more secure is a very, very good idea. And I think it's worked out like that across the board. Now, a word about why we choose Azure. And I want to prefix that with the statement that we don't necessarily always choose Azure. We are very much a cross-cloud kind of organization. We've done stuff with AWS in particular is one that we also like, and you've seen me probably do some presentations on AWS before. But it is fair to say that the majority of things we do on Azure. And there's a reason for that. One of them perhaps is that we've always come from a Microsoft angle and been a Microsoft store over the years. But AWS also integrates very well with things like Visual Studio and .NET. But what we like about Azure is it caters very much to the enterprise level, to the well-integrated type of setup. I really enjoy the way the Azure portal works, for instance. And whether you like all the details of the interface, different story, but the fact that it's all well thought out in one place and everything is right there is something I really, really like. And so I feel for the typical business application, Azure has a very, very strong offering that is very well thought out and very well integrated. So take that for what it's worth, just my personal opinion. We're not getting paid by Microsoft for doing this or anything like that. It's just what our personal preference is, what we see works well, and what we see works well for our customers and magazine readers and people we see in training events and stuff like that. But don't dismiss other clouds. I've now said it a number of times, AWS is pretty darn good as well. So let's go ahead and dive into some of the specifics around Azure. Now, if you've never done anything with Azure, let's take a quick look around what Azure is like if you have never actually gone into it. And the first thing that most people do or should do when they talk about Azure is they use the Azure App Service. What is that? That's in a way, think of that as hosting your website in the cloud. It's just this thing out there that runs on a number of servers. You don't really care what that means. And it allows you to run your web app, whether that is an ASP.NET Core web app, whether that's a service like a REST-based API or a microservice, whether that runs on Linux or whether it runs on Windows or whether it's an older style .NET application, all the way back to web forms, or whether you're a PHP guy or whatever. Microsoft really doesn't care. This is not just about .NET. This is for everyone. Okay, and that's in a way the most fundamental thing from a developer's point of view that you can do on Azure. Now let me just show you what this looks like, and I've already logged into Azure here. So what we're looking at here is the Azure portal. If you go to portal.azure.com, this essentially is what you'll see. And if you don't have an account yet, you can sign up for an account for free. Doesn't cost you anything. You'll probably be surprised to hear, if you've never played with any of this, that quite a bit of stuff on Azure is completely free of charge. So if you were to create a website that you needed hosted somewhere, you could go here, you could say create a new resource, and then in here you can pick what kind of resource you want to create, and you'll find literally hundreds of things at this point that you can do, from creating websites to creating databases to all kinds of stuff. Now, if you're familiar with this, you're like, oh, okay, get along with it. But just to show people that have never done any of this, how easy and straightforward it is. So we can search in here for different services. So let's just search for app, and then the marketplace brings up all these different things that you can do. That's fine. And so I'm just going to choose the web app service here, and I'm going to click create. And now I can go through here and I can pick a few things, like I can group this into certain resources, like I have this resource group for my demonstrations. I can give this a name. Just call it the Stata.NET Simple Web App. Now this needs to be unique, so it can be exposed in a proper way. We can choose the technology we want to use. And you see there's a lot of different stuff in here. In our example, we'll just use .NET 6. We can then choose the operating system. I'm going to choose Linux here. Why am I going to choose Linux? Linux is turning out to be very, very cost efficient and very performance efficient for running websites. And in fact, when we first started using Azure, we did everything on Windows because we're a Windows shop, right? And then with .NET Core, of course, it became much more feasible to target Linux. And as it turned out, we saved more than half our money by moving to Linux-based websites, and the performance seemingly is better as well. We can then choose exactly the size of the machine or the resource that we have. Often this is not really machine specific, it's just, I want this much power. And then I can go ahead and just click create. And this will now provision a scenario behind the scenes where we can create, or where it creates for us this web application that Azure is running for us. And so this is going to take a moment. While this is going on, actually, I think it already completed, but while this is going on, what we would do on the back end, we would simply say create a new project, and we would pick an ASP.NET web application, just whatever, pick that and name it something, doesn't really matter, and just create a simple app. So this is the same app that you would always create using .NET Core is just one example. And of course, I could now fire this up and see what it does. Not surprisingly, this is the default template that we always get. And the point I'm making here is that it's really not technology specific, right? You can host just about anything you want in Azure. And somewhere this is going to start up. Here's our awesome web application. You've probably done this a million times. And in the meantime, our deployment has been completed here. So now here is like standing up a whole new web server for us that has all kinds of benefits, very manageable, very scalable, and so on. And it even created a default URL for us, although we can change that. And here is this website just kind of parked waiting for something to happen. Now we could now target publish to this, and there's different ways of doing that. One of the ways is to say, give me a publish profile. And this will download this publish setting file. And we can now go back to Visual Studio. We can click publish here. It doesn't yet know where we want to go, so we can say import the profile that just got created. And so I'm going to go into my downloads and pick that profile and say finish. And now we have everything we need to connect to Azure. And we can go and we can click publish here, and it'll go and compile and package it all up. And then we got some error. Build failed. We can do that again. Oh, it's not happy. Let's see. Let's do that. The publish profile included a few different ways of publishing. In this case, we're publishing, should be into a Linux-based distribution. Let's see what it does. I might have picked something wrong, but we'll see if it goes through. Looks like it's doing something, packaging things up down here. Pushing up the root folder. And as you do this subsequently, it goes faster, first of all. And secondly, this right-click publish out of Visual Studio is probably not what you're going to do for long, right? It's a great way to get started. But then, of course, DevOps kick in, and you probably want to put this on more solid legs and have more automated and controlled deployments. But that's not the purpose of this demo here. This demo is to show you how straightforward it is to do all the involved steps, soup to nuts. And now it's distributing Bootstrap and all these things that for the first deployment it needs to do, and then subsequently doesn't have to do every time anymore. And I think we should be almost there. because it always takes particularly long when you try to demo something like this. Okay, come on. Now would be a great time for some questions. And I'll give it a little bit longer if it doesn't finish soon. You kind of get the idea. This is really the last step of my quick little demo here, in that we should now have that web application show up publicly. And if you're actually following along here live, then rather than watching this as a recording, you'll be able to even go to this URL once this finishes here. Apparently there's a lot in the CSS folder here for Bootstrap that it's trying to shovel up while I'm also doing streaming. So maybe we'll return to that in a little bit. But long story short, this is essentially what it takes to create a new application, both in terms of the development experience as well as the IT infrastructure experience. Because when you think of all the things we've now done, we started from scratch without having a server or anything, and provisioned everything in a relatively short amount of time, assuming that this demo will finish sooner or later. Yeah, it's done with the CSS, now it has the JavaScript, and in any event, we'll return to that in a little bit. So that's an Azure App Service. It enables you to run your web application. It enables you to run anything that's kind of HTTP based at a very rudimentary fashion. It's a step up from having somebody provide you a box in a data center somewhere that's co-hosted and just operate it for you. Except when I say a step up, I mean you don't have to worry about updating it, you don't have to worry about backing it up, all that type of stuff. There's a question online. Does code typically use the highest level service, or do you tend to start with VMs and manage everything you would in your own data center? Well, we try to avoid VMs because we try to avoid that very task of having to maintain our VM, update the VM. The VM consumes a lot of resources even when it's not very busy. It's a cumbersome and expensive way to go. So if you're using a service like Azure App Service or some of the higher level services that I'll show you here in a moment, you sidestep all that. It usually works better, it scales better, because what do you do if all of a sudden you discover, darn it, we're really busy and we need, rather than one server, we need 10 or 100? Well, then you're provisioning all these VMs and you're spinning that up and you're figuring out a way to load balance that. And none of that you really need to do because it's already provided for you using things like app services and many things that build on top of that. Oh, and here is our deployment finally done, and presumably, see what Visual Studio said. It succeeded. So we should be able to go to this, and it's actually not refreshed. Well, in any event, you get the idea. This is the steps that you normally go through. So yeah, so we absolutely use this. And also, this service is very fundamental. It's kind of the entry-level service. But at the same time, it's a service we do use every day on almost every project we do. A lot of people will make you believe you have to use all this amazing infrastructure with these really high-level services, and often you don't need it. I did a Stata.net just on architectural thoughts, and one of my key architectural thoughts that I often like to share with people is you don't need to use all the really expensive high-end services just because Microsoft offers them and likes to cater to the largest of the enterprises. This service, while simple, is one that will be useful to you almost every day. Now, a question online is if a platform as a service offering is updated by Microsoft, what is the best way to see if anything has changed recently? It's an excellent question. And every time a presenter says it's an excellent question, it means he doesn't have a good answer, right? So that's kind of true here. Azure is almost, it's the proverbial drinking from a fire hose. There's so much new stuff being rolled out on a day-by-day basis. It's impossible to keep up with everything. It's almost like saying, what's new on in the Windows app ecosystem, right? There's no way to keep up with everything that every company is doing. Probably one of the better ways is to look at some of the blogs. There's an Azure blog, and then of course the .NET blog relates to Azure a lot. And then some of the teams within Azure, say you're using SQL Server on Azure, has their own blogs. And so you can stay up to date with it like that. But it's a task. Now, most of the time, you don't really need to know. If you have something that's up and running, it'll keep running. It'll get patched. If there's a security problem, Microsoft will take care of it for you. So you don't have to keep up to date with it as much as if you were running your own stuff. Okay, so that's important to realize. So anyway, let's move along here, because this was kind of the basic of the services, and we've talked about that. Related topic to this is kind of interesting, static web apps. In fact, the Eagle Eye observer may have seen a checkbox, and I went through my example there where I could have chosen and ticked the checkbox for static web app. What this is a type of web app that runs highly efficient, in that all it does is serve up static content to a caller. And that often works very well if you're building an app that's a single page app, the Vues, the Angulars of the world, React, that really just download HTML and then run everything on the client. If you have that, then of course the server resource can be managed highly efficient, and that's what a static web app is for. And one of the things that's nice with static web apps is it has a very, very tight integration with GitHub. So if you're using GitHub, as more and more people are, and GitHub's becoming more and more integral to this developer experience, you can just push your content into a certain branch in GitHub, which triggers a webhook and then automatically deploys as a static web app, and it's a very seamless process. You can, by the way, do something very similar also with other types of web apps, like the one we just created. Now let's dive a little deeper into some of these higher level services. And one of them that often goes overlooked is Azure Functions. What's an Azure function? Well, if you read the docs, or if somebody tells you about it, they always tell you it's this serverless thing. At which point people say, what? There's no server? How does that work? Well, that's not what it means, actually. Serverless is kind of an odd term in that sense. But serverless just means you don't worry about whether there is a server, how many servers you need, whatever. You just have something in the cloud that runs your stuff. And that's one level higher to what we've seen before, because in this web app, we did behind the scenes create a server, and we had means of saying scale that to multiple servers if we dug into the configuration of all that. And so it would be relatively seamless, but we do kind of worry about there being servers that need to be managed a tiny bit at least. Serverless means you don't worry about that at all. You just hand it over to Azure and say, do it. And if I need more oomph and more processing power, Azure will just take care of it. And I'm not worrying at all about how many servers there are to make this happen. So Azure Functions is kind of the key of this. And if you're in the Amazon world, this would be Amazon Lambdas. And it's kind of really cool. So you can go into this portal, and just like we created a web app, you look for functions and you say create a function. And then you can either create individual functions just as scripts there, or you can actually create something like a Visual Studio project or use some other development tool and then publish into the function. So at the end of the day, it's not all that different from what we've just done, except of course, functions are usually made for API calls, for microservices, for things that need to run on a schedule. And that's where functions really shine. Functions respond to something that happened. Right? So functions respond, for instance, to a timer event. I want to do something every day at midnight, run this. Or it could respond to an HTTP request, which is, that could be an API call, right? So it's perfectly feasible to implement REST-based APIs, as an example, using Azure Functions. And the cool thing is it's all managed for you. It scales up, it scales down. You can go all the way to 0. So if you have something that needs to happen once a month or once a week, this is awesome because it goes to 0 and you're not paying for it while this thing doesn't do anything. The downside of functions is, excuse me, when it scales to 0, the next time it gets hit, there is what we call a cold start penalty, because things have to start up. Microsoft doesn't keep it running and in memory while this is not being used. So this cold start penalty is a little bit of an issue with functions. You can keep functions running, but then of course you're not getting as much of a cost benefit out of them. But it's a very, very interesting feature set and very, very powerful because it has all these different ways of triggering functions. And so we have some microservices, for instance, that need to run every day at midnight. Well, how do you do that? Now you need to create your own scheduler and that needs to trigger it. And how reliable is that? And well, just make it a function. And then you can use the built-in feature set in Azure Functions to make that happen. So cool stuff. Encourage you to check it out. Now going back to our web application. So let's say we've created this simple web application or let's say a web service, something that returns data, typical microservice or API type of thing. When that happens, a lot of people will tell you stick it into a container. A container being the self-encapsulated thing that's almost like a small virtual machine for your app. It has everything that your app needs containerized. And what we're talking about there is Docker containers, is the technology that's used for that. And Docker containers have been around for a while. They can be used in any number of ways. There's the Docker orchestration, the Docker container registry, all kinds of stuff. But what has evolved over the last few years is this technology called Kubernetes. Kubernetes is a way to manage these containers. So the way you go is in Visual Studio, you create your app, you enable Docker support, which is one of the check marks I unticked in my prior example, and that compiles a Docker image, a container image for you that you can then deploy. And it's guaranteed to have everything you need. And it solves this problem of, oh, it runs on my machine, but not on yours. Everything is in that container. And then you deploy that container, and then Kubernetes can do things like instantiate 1,000 of them if that's needed. And that's really, really cool. And Kubernetes has turned out to be the winner in all these container orchestration scenarios. So that's the technology that everybody uses. But Kubernetes has the downside that it's kind of a pretty heavy hammer, right? It's something that you need to understand. It's something that you need to manage. It involves a Kubernetes cluster. That means you have a number of things running, which is certainly more expensive than the app service we just did. Now, if you're an enterprise, that's all fine because you need large scale anyway, and that's going to cost some money. But it would be nice to get some of that and not have to jump through all these hoops and take on all these expenses. And that's what Azure Container Apps is. It's a new solution. It's been around since build a few months ago, is when it became a released version. And it takes everything in Kubernetes, it builds on top of Kubernetes, except it abstracts a lot of this stuff away from you and just makes a nice container solution that can scale up and down and just has a few settings that you can choose, scales down all the way to 0, meaning if you're not using it, you're not paying for it. Has a little bit of that cold start penalty again. But it's a good solution for that sort of stuff. And if that becomes too small for you, you could then always take it into a real Kubernetes cluster and use the Kubernetes APIs and all the management tools. But this, for most container solutions, is really awesome. Now, I have another sample here. And in this example, the wait states that we have when deploying are far worse than in the previous example that I've just shown you. So for this reason, I actually went and I sat down yesterday and I recorded this example. So let me run this recording for you now to see me do that. So here we are in Visual Studio. I'm using the latest preview version of Visual Studio here. You could, of course, use any other tool of your choice like Visual Studio Code or many others. But Visual Studio, as in the full version, really has made a big comeback in this recent edition or recent version. So that's what I'm going to use here. So what we're going to do is we're going to start a new project. And this could really be any kind of project that you're building that would run as any kind of web type of application. In this case, I'm just going to create an ASP.NET Core Web API app. And I'm just going to call this data.NET container. Stick it in my test folder. I'm going to pick a few different things here. I'm going to use .NET 6 as you should use at this point. No reason to go back to .NET 5, as you know. Very compatible with 6. You should always pick 6. I'm I'm going to leave some of these things in place. HTTPS is fine. We don't need Open API. We're also going to create something very simple, so we don't need to create controllers. But all of that really has nothing to do with container apps. I'm just going to create the simplest example possible. Now, what is important, however, is that you enable Docker in here. Now, this implies a few different things. Most importantly, that you have Docker installed on your system. Now, that's one of the little flies in the ointment that we still have that makes containers a little bit out of the ordinary, because you need to install the Docker desktop app and you need to configure your system to run that. So if you don't have that installed and you pick this, Visual Studio will ask you to install this and basically trigger the install. If you're agreeable to that, it'll then download Docker Desktop. Docker will then ask you during the install whether you want to run this on the hypervisor or on WSL2, the Windows subsystem for Linux, which is what I choose at this point. It's kind of the most modern way of doing this. And then once that install is done, you can start using that. So the first time around, that may take a little bit. And like I said, it's a little bit of a fly in the ointment. It is what it is. I'm sure it has a little bit of a flair of some assembly required. And so that's certainly something that I wouldn't be surprised if Microsoft takes a look at making smoother in the future. But for now, that's just something you got to be aware of, but it happens pretty much automatically. Also, what you need to be aware of is while you can pick whether you want to run Docker on Windows or Linux, currently Azure Container Apps only support Linux. And that really makes the most sense anyway. And just as a little bit of a side note, we pretty much always choose Linux at this point, unless we have something that's Windows specific and can only run on Windows. But out of all the services, for instance, just to give you an idea that we are running in our own infrastructure, we only have one service that has that limitation, and everything else we run on Linux, and it cut our Azure bill more than in half. So definitely something that is highly recommended. In any event, we're going to go ahead and we're going to create this application. And this creates the typical ASP.NET core API, web API type application, in this case, using minimal API. So we just have a program file. And in this program file, we just fire up the app and we respond to a /weather forecast request. So this is the standard sample. It's always used. And this could be anything, of course. Now, also, you'll see that we have a Docker file in here. You don't really need to know what that means, but this is basically the build instructions for Docker to create a Docker container. So if I just go ahead and I run this, you see it defaults to run within Docker. So when I do this, it starts to build this application. And it then opened up here on my other screen. So let me bring this over here. And so as I go to this URL /weather forecast, it just goes and it runs the sample app and returns the data JSON serialized, which raw looks like this, but we can look at it parsed here in our Edge browser like that. So nice, so that works, no big surprise. What is a little bit unusual here is that this just ran within Docker. So if you've never done anything with Docker, you may not even really see a big difference here, but what's happening in reality is that this whole thing got packaged into a Docker container and now runs inside the Docker container using Linux. And so it's just an app virtualization mechanism that works on our behalf there. And we could now do a number of things with this, including deploying it in different ways. So we could either deploy it natively to Docker, we could deploy it to Kubernetes if we were really into all those details and we knew how Kubernetes works and we wanted to use the Kubernetes API. And all those things really that were the most likely things that we'd have to do without Azure Container Apps. But since we're using Azure Container Apps, we can now go in here and we can choose Publish. And now we pick Azure as our publish target. And then we pick Azure Container Apps as our specific target in this case. And this is really the first step where my demo here diverges from any other containerization demonstration, in that we go into this specific Linux-based Azure Container App. And as if you've played with this a little bit earlier, you know that this used to be in preview. This has now been removed. It's now a regular version. So we go ahead and it says, okay, well, what Azure subscription do you want to use? I have several, so I can pick one. Now we don't have a container app created yet. We could go into the Azure portal and do it from there, or we could, of course, use the Azure CLI. That's, I guess, in the professional world, one of the most common scenarios where we have a command line interface and we do it from there. And of course, all of that is supported for Azure Container Apps. But for now, we'll just go in here and we'll use the UI, because why not? So we'll give this a name. We'll call this this data.net container. And it always wants me to do all lowercase characters here. We can then use a certain resource group, and I'm just going to use this one. We can then also create a container environment, which is kind of a boundary around multiple containers, basically. We'll call this data.net container environment and put it into the same data center. And we'll fine with this. And then we click create. And this takes a moment now, as it creates this container app in the background. So this now goes out and it does everything within the Azure portal to create this container application. Or again, you could do this through the CLI. Takes a little bit, especially the first time around you do this, so bear with me here. And there we go, our container app got created. And what this basically did is it created, if we want to think of it this way, a container image that contains everything that this app needs to do in a containerized version. Now, the next step is we also need a container registry. A container registry is where all these container apps go. And the registry is then the orchestration around that says, okay, we have this container app that we now know how it works. And as needed, can we create instances out of that? So if somebody hits that, maybe we start up a first instance, or maybe we have too much traffic, then the registry knows how to create multiple instances and scale it and so forth. So again, we don't have that either, so we create a new one of that as well. Call it the data.net container registry. And that's all fine. Hit create again. And again, this is going to take a moment. And there we go. It is now done by the magic of video editing. I cut out some of that wait state there. So now we have that registry completed. And now we're basically ready to go. So we say finish. And what it does now is it creates a publish profile for us, which we can use to then publish into this registry and this container app that we have now created. It's a little bit of a confusing step here. Some people go, why doesn't it just publish now? Well, no, we just created the Azure things that we would have normally created through the portal. And now it automatically created a publish profile for us that we can now use to publish to this thing. We could have also taken the other route, could have created the container app on Azure first, configured it there, then gotten the publish profile. And now we can go ahead and we can publish from within Visual Studio. So it's now pre-configured with this new publish profile, and we can now hit publish, and it goes ahead and it actually publishes this to Azure. And we can watch how this goes. We have all the different settings in here. Now, of course, we could go into the Azure portal, which in fact I will do at the same time here while this is going on. I'll bring up my Azure portal here. And we will refresh this and go to the correct resource group. And here we now see these different things that Visual Studio created for us in our Azure environment. And we could now drill into this. We could set different settings. We could do things like the scaling. We could set things like domain names, security setup, and so on and so on. But in our case, we just happen to do that out of Visual Studio, and we're now publishing directly out of Visual Studio. Again, the publishing directly out of Visual Studio is probably not the most likely thing you'll do in a large production environment. You're probably using the CLI. You might actually publish into or push your code into GitHub and then use GitHub Actions to pull this information out of GitHub. But this is certainly one way to go for for playing around with it, for doing smaller things. It's not like you can never use this for production. So smaller things you can certainly do like this. And again, it takes a little moment the first time you do this. Second time around, it'll go, or subsequent times, it'll go faster. And also, as you publish multiple times, by the way, it will create revisions and snapshots, so you can revert to a prior version of a container and so on. But in any event, we now have this Azure container app running. And we can now go and we can hit our weather forecast, and you see that this now runs in the cloud. If you were to type in this URL right as I am doing this demo, you could see this now publicly. The URL, by the way, is just the default one that it created. You can configure that through the Azure portal or through the CLI. But long story short, we've now created an Azure container app from start to finish, including everything from the Visual Studio project. And again, you could use any type of Visual Studio project you want, all the way through creating the Azure resources required for this. And there's very, very little compared to a Kubernetes setup. As you saw, we provided a few names. We didn't really have to know very much about all of this. And that's really one of the main benefits that we get out of this. And we could now take this and we could say, okay, well, we've outgrown this. We really want to use a Kubernetes API. And then we just go seamlessly into Kubernetes, because behind the scenes, it's all based on that. But for the majority of users, this is probably exactly what you need. So it's a pretty exciting new feature. One of the cooler things that's come our way in a long time, I think, or one of the things I've been really waiting for as far as Azure services go. Okay, so that's my pre-recorded demo for the day. I think you saw it. There were 2 instances where I cut minutes out of it, because the first time when this gets deployed, it actually takes a while. But this is cool stuff. To me, containerization is very, very exciting. And what Azure Container Apps is now doing for the first time, it really makes containerization available for the majority of types of applications without incurring that massive overhead and maintenance and in setup and orchestration and all that. So that's why I spent quite a bit of time showing you this. And I always have to pick and choose the features that I want to show. But this to me is one of the more exciting things for the vast majority of developers that has come out of that kind of fundamental Azure environment in quite a while. Now, as I mentioned, this is all built on top of Kubernetes. If you want to, you can, of course, use Kubernetes, and that's all still there. In fact, Azure Container App is built on top of that. It's an abstraction of the Kubernetes service. And very often what you can do is, as your app grows, you then take it into Kubernetes, or you take a few containers into Kubernetes, and then you have all the power that Kubernetes provides. And that's one example where I say the wheel is spinning in Azure, new things are coming, but it's not throwing out old stuff as much as it used to. Yeah, we have Kubernetes and now we have container apps on top of it, but they're really the same thing. It's kind of standing on the shoulders of giants. But Kubernetes, of course, is still there. I did a session previously at State.NET on architecture. We talked quite a bit about Kubernetes architecture, when to use it and when not. It's a very, very cool thing, very powerful. But you don't need it all the time. It's just quite a bit of overhead for running small things. And the truth is, if you're using a microservice architecture, unless you're really, really large, each microservice is probably relatively small. And then you may not need this. Now, looking at a few of the other services, I just want to touch on some of the things that are there. A lot of this is very stable. Azure storage is a very, very important thing. We've talked about that a number of times. It's the ability to store stuff into Azure, almost like your drive in the cloud, but not in the sense of a OneDrive or a Dropbox, more in the sense of programmatically storing things, blobs of data, weakly structured data, just kind of files that you put in a place, but it's not like it's like a hard drive, but it's structured a little bit different. Right? So high performance ways of storing data, lower cost ways of storing. There's different tiers of all this, and very, very easy to use. So that's important. I also want to mention SQL Azure here really quick. There's any number of ways of putting databases into Azure, but if you're sitting in this presentation today, you're probably coming from a Microsoft angle. and SQL Server is going to be very, very interesting for you. So SQL Azure is Microsoft's purpose-built version of SQL to run in Azure. You can also take and use SQL Server on Azure, which is essentially moving it into a virtual machine, which is often a very simple way of moving into Azure quickly. And that's what we did when we got hit by a ransomware attack. We moved all our data into SQL Server running on Azure. But that runs in a VM. It's a little more expensive. If you go to SQL Azure natively, which is the native offering, purpose-built for Azure, like I said, then that almost works identical to SQL. It's a little bit of a more modern version. It also is a little bit of a decluttered version. So some field types, like, you're using varchar max versus a text field. Some minor changes like that, but not bad, actually. And so it took us a half hour to change the structure of our pretty massive databases to support SQL Azure. And then that runs just much more cost efficient. So that's the one you should be going with. And this is also being developed very, very nicely. Lots of cool features in there. One of the nice cool features that was added recently is ledger support, which essentially means having a blockchain type of system within SQL Server if you have immutable data that needs to be very trustworthy. So rather than using an Azure blockchain service or any other kind of cloud-based blockchain service that does nothing but blockchain, you can actually now kind of use that baked into SQL Azure, which is a very nice feature. And blockchain's not the flashy buzzword type of feature anymore, but it's kind of gained momentum quietly now and is being used for more serious things. So that's kind of cool. And talked about that. An alternative database, and there's many, and Microsoft supports third-party databases like MongoDB and all kinds of stuff on Azure. But an alternative offering from Microsoft is Azure Cosmos DB. It's a NoSQL database built specifically for the cloud, serverless, scales basically infinitely, and geo-replicated, and it's very cool in that you can access it basically where it looks like different things, like it may look like a document database, but then you can also access it like more of a SQL type database. Pretty cool offering, actually, something that we use a fair bit, I would say. And that's an example as we're moving up the ladder now, going to kind of higher and higher level services. Now, there's no way I can give you an overview of all the different services that are available on Azure for developers because there's now basically too many. So these are all still very, very specific. Now, in addition to the services that are useful for us as developers to use and run something, of course, the cloud also does other things for us. Like GitHub, for instance, is a cloud offering that provides us stuff that helps us develop rather than run stuff. And this is something that always comes up. What's the status of GitHub? How does it relate to other things like Azure DevOps, for instance? And I added this slide here because I wanted to make the point that GitHub is very rapidly becoming the center of the development ecosystem. Everything revolves around GitHub. And it's now beyond just source code repositories. It's beyond even just DevOps, which DevOps, of course, is a big part of it. But GitHub is really starting to evolve into this central place, and they're leveraging what they have in any number of ways now. And for those of you who don't know, GitHub is now owned by Microsoft. And one of the really cool things that came out of GitHub is GitHub Copilot, which is now available. In the last State.NET, I did a presentation, I had a demo on using GitHub Copilot, which is an AI that is trained on this ginormous code base that GitHub has and uses that knowledge to help you create code. So if you want to think of it like that, it's intelligence on, all the way turned up to 11. So if you're interested in that, or even if you aren't, I recommend go back, look at that demo I did at the last State.NET, just a few minutes long, but it blows your mind as to what this thing can actually do and how wickedly smart this is in helping you type. So a lot of things that in the past you went to Stack Overflow for to find how did other people do this, you don't even need that anymore. Often you type a method name and it kind of knows what you do and it makes suggestions as to how you want to do it. So mind-boggling. I recommend you check this out. Another example that's coming from the cloud that helps us developers is currently in private preview, and it's called Microsoft DevBox. This, in a nutshell, is the ability to run a virtual machine in the cloud that is your developer machine. So if you say, I need a really powerful machine because I'm a game developer and it needs this and this and this installed, Visual Studio and DirectX SDK and whatever else, then this is for you. If you're a business application developer developing services and web apps and maybe Maui-based mobile apps or whatever, this is the service for you. It's a quick way to spin up developer machines, access them from anywhere, high performance, and you can create all these different environments, and just a really good thing to do. I've several clients, one in particular comes to mind, that tried to create something like this with regular VMs, where the developers can spin up VMs relatively quickly. But it's a massive effort keeping the images up to date and all these different environments that people may need. And then you have all that set up, and now there's this new thing that you don't have a VM for. This is going to solve all of this, and I think it's going to make this much more feasible and just so much easier to set up a VM for a developer to work on going this way. It's not available yet to everyone, but this is coming relatively soon. So this is a sampling of things that happens. Now, how do you start moving into this world? And again, this world is so much bigger than I could show even in a day-long session, but hopefully this kind of gives you a first idea of important things that are there. But I want to talk a little bit about how do you migrate to this, because that seems overwhelming to a lot of people. And the reality is it's not that overwhelming, okay? So migration can be very gradual. You can often take it in steps. You can often take it by moving things into a virtual machine. We are talking to a customer right now. They're running everything in their own data center. They're hosting websites. They're hosting services. They're running SQL Server and other databases. And it's like, well, how can we move all of this to the cloud? It requires massive changes. Well, no, not really. We can take that and stick it into a virtual machine and move that up as a first step. And same with the database, same with the services, same with the web apps and so on. And then you gradually start. Maybe you're starting to move SQL Server into SQL Azure. That's probably very easy, and now you're more cost efficient. So that's really, really cool. Migrating apps that are web apps, that are services, microservices, REST services, is generally quite easy to do, as it turns out. So that's certainly something that helps. Microsoft also offers hybrid scenarios. Microsoft's really good at that, where maybe you put some stuff into the cloud, but you're still wanting to hold on to the database, running that in your own data center. Microsoft supports that as well. And so there's different ways of doing this. And the key takeaway here is it's probably not as hard as you think. And like I said, we had a pretty sophisticated environment that then got taken down by this ransomware attack a few years ago. And all of a sudden we had to take this plunge, and we're kind of like, that's going to be hard. We could do it in a matter of days, which really blew my mind. And yeah, it was well architected and all that, but it was much, much easier than we thought. Now, of course, if you want to take this to the logical conclusion, you're building something that's cloud native. What does cloud native mean? Cloud native basically means you're building something architected for the cloud with all these amazing services in mind that we've now started looking at a little bit. Okay, so the things you're building are fundamentally built on cloud concepts, serverless computing, the way you call services, the way you use things like AI, the way you use databases that scale, all that type of stuff. If you're doing it the way the cloud wants you to do, you're cloud native in simple terms. And that's your ultimate concept now, or your ultimate goal. But it's a concept that you don't have to swallow whole. It's something that you can use in chunks, so you can create additional things to your existing apps using this cloud native approach, and then you're gradually moving into that more and more. And so if you have the typical conventional apps, maybe even Windows apps, you can probably use this stuff. And in fact, I want to show you something that we are actually running in our real world environment. So this is software that I'm about to show you here, that we are running in-house at Code. And we're using this for all kinds of stuff, like managing magazine subscriptions, managing events like this current Stata.net presentation and who signs up for it. We manage all our customers through this. We manage all our articles through this. And so I can go into this application here, and dig into this article system. And so, for instance, I could go in here and do something that's relatively conventional and look at, say, articles that we have in our database that were published by a certain author or that were published in a certain magazine. And by the way, this whole application that you're seeing here doesn't necessarily look like this, but it is actually a Windows Forms application. It's an application that's evolved over 20 years or more, okay? And so in this app, I could now go in here and I could do something like this. I could look for our articles that were published in the, whatever, NoSQL database category. Now, in this case, I'm not actually looking for a category called NoSQL databases, but this is just a single text search that we have here. Now, when you think about this, it's what everybody wants to do, right? You go to Google and you have a single text box and you search with that. But when you think of how do I implement that in my own application, it's actually a difficult thing to do, because what you want is you want something that isn't an exact text match, but what you want is an intelligent search that returns the most likely thing that you looked for in the order of significance. And so when we look at what came back here, is we see now all the different articles that we have in our database from Code Magazine that had something to do with NoSQL databases. And it can be something different, like here, what's new in RavenDB 2.5 is something that came up. We published that back in 2013. And that's a 12% match for what we wanted. And we could now dig into that and we could look at what's going on in here, and we could look at the actual magazine content. And yeah, it's kind of a cool application. Doesn't look too bad, even though it's a WinForms app. Even does a few funky things like different themes and so on. So what we were able to do is we were able to take this existing application, this typical rich client WinForms app that's evolved over 20 years, and we are pairing it with cloud native technology. So what happens here is when I do this kind of a search, we are actually pinging Azure behind the scenes, and we are triggering a cloud native intelligent search that has indexed our database and of articles, and we are now retrieving from that database in a ranked, relevant way, providing a very, very modern approach to search. Now, how does this work exactly? Well, when we go into our portal here, we can look for our search services. And as it turns out, there's something in Azure that's called Azure Search, Azure Cognitive Search. It's a search service. So we can create this just like we create our container app, or like we created our web app. And we then go in here, we configure this, we say how big is this going to be, and then we can start creating what's called indexes. An index is the search term in the world of search, what we would call a table in the database world. And so we start sticking things into this search, and we could actually go in here and use this search explorer and start looking for things. So that's the wrong one. So we could come in here and we can look for, I don't know, MongoDB, and trigger a search. And down here you see the actual URL that is being triggered by that. And here is the JSON data that comes back for this search. It's the data we stuck into our database. It mirrors what we have in SQL for our articles. It gives us back a relevance score somewhere here, and it sorts it by relevance. And we could now simply hit this URL. Now, if I just did this right now, it wouldn't work because we have security configured on top of it. But conceptually, depending on your configuration, you could just make web client requests into that. But what you would more likely do is you will create something like this. Here is a microservice that we use for this that integrates with it. And it has a search method in here. And what this does is it uses a package, a NuGet package that Microsoft provides that has this let's go into this one more step, that has this ability to use this search client that's provided by Microsoft. And with that, we can then use this from C# in a strongly typed fashion. And it becomes very simple. We can just provide it a few search terms. We provided the fields we want back. And then we basically trigger the search and we get back a collection of these items. And then we massage them a little bit and return them as a REST JSON type service. So very, very exciting when you think of what we just did. And really, this is one example that is driven by a cognitive service, by machine learning, by AI, to provide us the most meaningful result in a very, very simple way, the way most people want to search these days. And I'm hard-pressed to think of scenarios that couldn't benefit from this when it comes to business applications. Anything that has to do with data searching, I should probably be able to do this. And this service allows me to tweak this. It allows me to say, when somebody searches, then the title is more important than the category or whatever the case might be. So very, very easy to use service and very, very powerful. And so that was one example that I wanted to show you where you can take gradual steps to make a real world old application take advantage of these cloud native technologies and gradually move them more into a cloud native type of scenario. There was a question online, can virtual machines be accessed via non-Windows operating systems? Yeah, virtual machines are really just that. They're virtual machines. They can expose HTTP traffic endpoints. You can RDP, remote desktop, into them if you have an appropriate client and have all the security gates open for that. It's just a machine in the cloud that can do anything from acting as a VM to acting as a server. Now, I'm not sure if this question specifically refers to the DevBox stuff, which is a VM optimized for actual development work. But yeah, you can then also access those from anything you want, including mobile devices. If you had to look, you're probably not going to do a lot of development on your phone, but if you had to look something up, you could probably connect to it as well. So that's a lot of stuff there. I'm already way over my time again. And in some ways, I feel I've only scratched the surface showing you some of the things, but there's so much on Azure now. But the key takeaway is, if you're not on Azure yet, it's probably easy to go into Azure or any other cloud for that matter. And there's other clouds out there that are really good too. You can gradually adopt things. You can start using bits and pieces to spiff up your existing application. And it's probably easier than you think to lift and shift more and more stuff into the cloud. And ultimately, you will probably have to do it either through a public cloud like Microsoft or through something else. But the requirements for modern applications have just changed so much. I think it's the easiest way to go is to use an offering like the Microsoft Cloud. Do I know the cost of DevBox is a question online. Is it going to be similar to Azure VMs, blah, blah, blah? Honestly, I do not. It's in private preview right now. We do not yet know what the thing is going to cost. Obviously, it's probably going to be competitively priced. Otherwise, nobody's going to buy it. But yeah, the answer is I don't really know. So with that, if there's more questions, I'll stick around for a while. I have a few more announcements here that I want to make you aware of. One of the things is we are hiring developers like crazy. We got a lot of very exciting stuff going on in the company. Some of it I'm dying to talk to you about. We'll probably have more to announce over the next month or 2 or 3. But long story short is we're building a very large team. We're building a very large community. So if you're looking for a cool position, either as a staff developer or as a freelancer, or you just want to join the community of code people, then we have some cool things going on. In particular, but not limited to, a lot of stuff is going on in North America, a lot of stuff's going on also in Europe, but we are also very aggressively extending our operations in Australia. And so if you're looking for a job in Australia or you know somebody, take a look at what's going on. We got some exciting stuff specifically for you. So cool stuff going on there. Jim has already mentioned during the intro that there is a survey that we usually send out after the event. You could do me a huge favor by filling this in. It's 12 questions, doesn't take very long, really helps us understand what people want to see in State.NET events, and also some of the other things we're doing, like we have this series of online events called Code Presents. So your feedback is very, very valuable and very directly shapes what we do in the future and what people are interested in. And just to sweeten the deal a little bit, there's also one of the responders is going to win a $100 Amazon gift certificate, and pretty good chance to win. So that would do me a huge favor if you could help me out there. Other than that, you probably heard the drill before. There's a free subscription available to Code Magazine. If you came to this event, you can click this link. Feel free to pass this on. The slide deck, by the way, will be available for download from the State.NET website within a day or two, and the link is in it, so feel free to use that. Feel free to pass that on to your friends. No strings attached. It's just a free subscription. And the recordings and slide decks, like I said, are also available on this URL here, codemag.com/state.net, or you can just go to stateof.net.com. And if you haven't done so already, subscribe to the YouTube channel. Click the little bell so you get notified when you have something new. There's quite a bit of content up there at this point, whether from State.NET or Code Presents, and there's going to be a lot more coming in the future. And another thing, all of this stuff is totally free, by the way. I'm not selling you on anything. There's not going to be a secret, small print type of stuff. This is just free. And this is another one of those things that people always ask us about after this presentation. They come back to us and say, oh, it's all nice and good, but how does this apply to my specific scenario? For that, we have this particular offer here. Get a free hour of consulting, and if it's an hour and a half, that's fine too. So sign up for that. Contact Jim Duffy, info@codemag.com. However, space for this is limited. It's a first come, first serve thing. It has been pretty popular, so we haven't in the past been able to do all of them, unfortunately. So first come, first serve on that. And finally, the next State.NET event is already in the books. It's September 28th, last Wednesday of the month as usual. And this time we're going to look at the state of AI and machine learning. So what I've shown you with the search, which was part of Azure Cognitive Services, is a very simple example of why AI-based services and machine learning services are so exciting for business application developers and many other types of developers. So there's a lot of stuff there. We'll talk about things like scanning forms and recognizing what's in forms. We'll talk about image recognition. We'll talk about language processing. We'll talk about the search again, probably. A whole bunch of stuff that's really, really cool and kind of blows the mind a little bit. So September 28th, I think the online sign up is already open or will start being available within a matter of days. So mark your calendars, and I hope I'll see you all there. And with that, we'll wrap it up. Thank you all for attending. I'll hang around a little bit longer for questions, but again, feel free to email us, info@codemag.com, and we'd be happy to respond to all your inquiries. So thank you very much. Hope you find this useful. Please fill out the eval, and see you next time.
This State of .NET webinar was sponsored by DevSkiller. DevSkiller is the industry-proven platform to assess and grow tech talent. Created by developers for developers, DevSkiller has customers in over 90 countries and candidates in over 150. And DevSkiller is ready to help you assess tech talent wherever you are.